This is still Chapter 9, Section 2 notes, and we are on problem number 29. Again, we are evaluating and or simplifying these problems. So for number 29, I have x to the 8/3 times x to the 1/3 all over x squared. We know when we have like bases, the rule is to add the exponents. So that means in the numerator, I have x to the 8/3 plus 1/3 over x squared. 8/3 plus 1/3 gives me 9/3. 9/3 is 3, so of course that's x cubed over x squared. And now when I have x cubed over x squared, or I'm dividing with like bases, I use the quotient rule, which says subtract the exponents. So x to the 3 over x to the 2 is 3 minus 2, which is 1, or x to the first power. And of course we just put x, we don't put the power there. Okay, on number 30, same thing. I have like bases, so I have x to the 5/2 times x to the 3/2. I add 5/2 to 3/2, and I get 8/2, which is x to the 4th power, over x cubed. Use my quotient rule again. I say 4 minus 3 is 1. That gives me x to the 1, which is just x. So both 29 and 30 gave me an answer of x. On number 31, I'm distributing a to the 4/5 into both things inside the parentheses, a to the 1/5 and a to the 2/5. So that means I have a to the 4/5 times a to the 1/5 minus a to the 4/5 times a to the 2/5. Well, a to the 4/5 times a to the 1/5, I add those powers. That gives me a to the 5/5, which of course is just a to the first power, or a, minus a to the 4/5 times a to the 2/5. Again, I add those exponents. 4/5 plus 2/5 is 6/5, so that's minus a to the 6/5. And I'm going to leave it like that. I could actually take the 5th root of a to the 6th, and it would give me a times the 5th root of a, but I'm going to leave it with exponents there. Or with rational exponents, I should say. Number 32, same kind of problem. I have t to the 5/8 times the quantity t to the 3/8 plus t to the negative 5/8. So I'm going to first show my distributive property. That's t to the 5/8 times t to the 3/8 plus t to the 5/8 times t to the negative 5/8. Now I have like bases, so I add the exponents. 5/8 plus 3/8 is 8/8. 8/8 is 1, so that's t to the first power, which is just t, plus 5/8 plus negative 5/8 is 0. They cancel that out, so that gives me t to the 0. And what is anything raised to the 0 power? It's 1, which means that gives me t plus 1. Final answer on that one. Okay, now we're moving on to using rational exponents to simplify radical problems. So when I have a radical problem like number 33, I want to first change that radical expression into an exponential expression, then simplify that rational expression, and then change it back into a radical expression. So I want it to be in radical form, but I want it to be in simplest radical form. So the first one, the rule says change the radical expression into an exponential expression. The 4th root of 3 squared is of course 3 to the 2/4, because the index is the denominator and the power is the numerator. Well, 2/4 is a fraction that can be simplified. That's 3 to the 1/2. And 3 to the 1/2, now I'm going to change back to a radical expression. My denominator is my index, so it's the square root of 3 to the first power. I don't need to write the 1, and of course I don't need to write the 2 to show that it's a square root. It's just the square root of 3. Okay, number 34, the 6th root of 3 cubed, I'm going to do the same thing. I'm going to first change it to a rational expression. That's 3 to the 3/6. because the index is the denominator and the power is the numerator. That gives me 3 to the 1/2, which is the square root of 3. Same answer, different original problem, same answer, square root of 3. On number 35, I have the fourth root of 49x squared y squared. I'm going to take that 49 and make it a base raised to a power. So what could I do with a 49 to make it a base raised to a power? 49 is 7 squared, so I'm going to make that the fourth root of 7 squared x squared y squared, which gives me, of course, in rational exponent form, 7 to the 2 over 4, x to the 2 over 4, y to the 2 over 4. All of those reduce to 1/2, so that's 7 to the 1/2, x to the 1/2, y to the 1/2. Changed back to radical form, that gives me the square root of 7xy. Because my indices all need to be the same if I want to put it back under a square root sign, I had to have all denominators of 2 here. That's why I needed to change 49 so that it was 7 squared, so that I could have the same index for all of them when I reduced that. On number 36, I have a radical inside a radical, so I'm going to move them individually. The fourth root of m is m to the 1 over 4, and then the cubic root of that would be that to the 1/3 power. And when I have a power raised to a power, remember the rule is multiply your exponents, that gives me m to the 1 over 12, and now remember the instructions said to change it back to radical form, so I'm taking the 12th root of m. The same thing on number 37, I have the 5th root of the cubic root of x, so move out, I have x to the 1/3, and then that to the 1/5, which gives me, of course, x to the 1 over 15, which is the 15th root of x to the first power, but of course I don't put the 1 in there. Okay, on number 38, the last problem from this section, I have the 9th root of 27 x to the 6th y cubed, and because I want to have 27 as a base with a power, I'm going to change that to the 9th root of 3 cubed x to the 6th y cubed, which gives me 3 to the 3 over 9 x to the 6 over 9 y to the 3 over 9. Again, remember, the powers become the numerators, the index becomes the denominators. So now I'm going to reduce those fractions and see if I can maintain my same denominator. 3 over 9 is 1/3, that's 3 to the 1/3. 6 over 9 is 2/3, so that's x to the 2 over 3. And again, 3 over 9 is 1/3, that's y to the 1/3. And because all of my denominators are the same, I can use that as my index, and I'm taking the cubic root of 3x squared y. And that's my final answer, and that's the end of your notes for section 9-2.